In this video, we will learn what is a linear equation and uses of linear equation in economics. There are many uses of linear equation in economics. In particular, here we will see supply and demand analysis, income determination model, and IES-LM analysis. Within income determination model, we have this 2-sector model, 3-sector model, and 4-sector model. We will see it briefly with some examples. I will try to keep this video short, and there will be a separate video on solve problems. Let us first try to understand what is a linear equation. So you can see this equation. This equation has variables like this equation has variable y and variable x, and all equation has two variables, variable y and variable x. The difference is that this equation has exponent 1, that in this equation y has exponent 1, x has exponent 1, and in this equation y has exponent 1 but x has exponent 2. Here you can see this is the exponent 2. Similarly, in this equation x has exponent 3, and in this equation x has exponent 1, here 2 and 3. So when the exponent is simply 1, then we say that it is a linear equation. And if it is other than 1, that is, if the exponent is different from 1, we say it is a non-linear equation. Why we call it a non-linear equation? Because when you plot this equation on a graph, you will always find a straight line. A straight line can be like this, and it can be anything, like it can be like this, and it can be like this, and it can be like this. So whatever, but it will be a straight line. Whenever you plot a linear equation, you will always find a straight line. Okay, but when you plot this non-linear equation, you will not find a straight line, you will find a curve. For example, the curve can be like this, it can be like this. Let me first remove it. Yes, the curve can be like this, or it can be like this, and there can be many shapes of the curve. It depends on your equation. I am not telling you here the exactly, I am not exactly going to explain this non-linear equation, because we will have a separate lecture on non-linear equation. So whatever shape it can take, like it can be also like this. So these all are this all represents a non-linear equation, or when you plot a non-linear equation, you will find always a curve, and when you plot a linear equation on graph, you find a straight line. Okay, so you have to bear in mind that this is how these equations are represented graphically. I am not going to tell you in detail how to plot these equations, because these are the very basic thing, and you may have learned it in your class 10, or you have started learning from class 5 or 6. So I am not going to so much detail, but you have to bear in mind that a linear equation always has a straight line, and non-linear equation always has a curve. So let us come to its application part, and we will see first demand and supply analysis, and we will only focus on non-linear equation. And non-linear equation means we will only focus on straight line. They can be like this, or they can be anything. They can be like this. So let us go forward and see what is the application part. Now let us try to understand how linear equation is used in demand and supply analysis. Graphically, you know that demand is a negatively sloping line or downward sloping line, and supply is a positively sloping line or a upward sloping line, and where they meet, this point is called the equilibrium point. Here equilibrium quantity is decided and equilibrium price is decided. So here I will not explain it much graphically, because I have to focus on mathematical explanation of this concept. So you can see these are the straight line. So we will have a linear equation because a straight line are represented by linear equation. Sorry, here we have to write P. So now these are the two proper linear equation. This is the equation for positively sloping supply curve, and this is the equation for negatively sloping demand curve. And in equilibrium, you know that quantity supplied is equal to quantity demanded. So you can write here quantity supplied and QS is equal to QD. Now putting the value of QS and QD you can find the equilibrium price. For example, in place of QS, you can put the value of QS. This is the value of QS. You can copy simply and paste here. And now in place of QD, that is quantity demanded, you can put this value. So now we have a proper equation that can be solved for P. Now you want to solve for P. What can you do? Here we will write 3P. This 2P will change its sign and it will become plus 2P. Here it is minus 2P, and now if it changes its sign, it becomes 2P. I am not going to explain how these rules work because these are very basic, and I expect that you know that how this rule works. And now here we already obtained, and if this 5 changes its sign, it becomes plus 5. Now you can solve it easily. 3P plus 2P is equal to 5P, and 10 plus 5 is equal to 15. Further solving it, you will find 5 is equal to 15 by 5, and this is equals 3. It means our equilibrium price is 3. This is the equilibrium price in the market. Now we have to find the equilibrium quantity. You know that equilibrium quantity will be same for both supply and demand because it is equilibrium at all. So in any equation you can substitute the value for of P, which is 3, and you can find the equilibrium quantity in the market. For example, if you put the value of P here, it will be minus 5 plus 3 multiplied by P, or in place of P you have to write 3 because we have find that equilibrium price is 3. Now you can write minus 5 plus 9 is equal to 4. So this is your equilibrium quantity in the market. You can verify that equilibrium quantity demanded will always also be 4 because it is a equilibrium quantity for a equilibrium price. So you can write here 10 minus 2 multiplied by 3 because we know that P is equal to 3. So 10 minus 6 is equal to 4. Same, we have find same value for quantity supplied and quantity demanded, and we have verified the answer that QS is equal to QD. So our equilibrium quantity is 4 and our equilibrium price is 3. So this will be our answer. I think this is a very simple application and everybody should know. If you have not read, you may confuse, but once you practice this, it will seem very easy for you. Now let us discuss another topic, which was, I think, national equilibrium model, income determination model. Now we will see how linear equation is applied in income determination model. In income determination model, we have 3 models. One is 2-sector model, and the second is 3-sector model, and the third is 4-sector model. In 2-sector model, this Y is called a national income, and by C and S we mean that this national income is either consumed or saved. And in equilibrium level of output, that's at the equilibrium level of output, saving is equal to investment. So we can write Y is equal to C plus I, that is consumption plus investment. But in this sense, Y is real output, that is total output, that whatever is produced in the economy, and it is wasted in either consumption demand or investment demand. So you can say that this is the supply, whatever is supplied in economy in form of goods and services, and this is consumption and investment is demand, where this supply is wasted. So Y is equal to C plus I. This is the two sector model. In three sector model, there is additional variable, that is government, because in this two sector model we assume that there is no government, and economy is self functioning. But in three sector model we assume that there is government, so government also demands something, that is government also spends something. They spend something, that means they demand some goods and services, because money is spent in purchasing goods and services. So we have this output is wasted in three types of demand: consumption demand, investment demand, and government spending, or you can say government consumption demand. So this is the three sector model. And now the third is the four sector model. Here the additional variable is x minus m, that is export. This x is export and this m is import. That, and simultaneously we can say this is the net export. That is, you subtract import from export and you get the net export. In this model we have foreign trade, but in earlier models, that is in two sector model and three sector model, we assumed that there is no foreign trade and the economy is closed. But in the four sector model, we assume that uh, we have foreign trade and our import and export influence the output of our country and other countries as well. So this is the brief explanation of this four sector model. Hope you are able to understand this basic element. Now we will take it one by one and see how linear equation is used in income determination model. Basically we need to find this equilibrium output. So we will try to do this using linear equation one by one. First we will see two sector model, then three sector model, and after that we will see the four sector model. Let us try to understand the two sector model. I have already told you that in a two sector model, this national income Y is either consumed or saved, and saving is equal to investment, so we can write Y is equal to C plus I, or you can say this Y is the real output, and this real output is either wasted in consumption demand or investment demand. That is, whatever is produced, it is demanded for consumption or for investment. And in equilibrium level, Y is equal to C plus I, that is this supply, the supplied real output is equal to the actual demand in the economy. So this is the equilibrium position. And the question may be asked that find the equilibrium value of Y, that is find the equilibrium national income or equilibrium level of real output. Simply say in algebraic form you have to find this Y. But you cannot find this Y until C and I is given. So when a question is asked like this, you are given some values, like for C you have given a consumption function, because this C is consumption and this shows the consumption function. And this consumption function is two parts. This is the autonomous consumption, that is the minimum level of consumption that we consume even if our income is zero. And the remaining part of consumption is not autonomous consumption. This is related to Y, that is we consume some portion of Y and this portion is represented by this B. And investment is assumed to be autonomous. Autonomous simply means that it is not influenced by any other variable in the model, so we call this is autonomous. Okay, so these two things are given, and if they want you to find the numerical value, then they will also provide this numerical value of C. Here for example we assume that C bar is equal to 40 and this B is equal to 0.6, that is we consume the 60% of our income, and this autonomous investment I bar is given 60. So this equation can be written like 40 plus 0.6 y, and this autonomous investment can be written as 60. Now we can substitute the value in this equation and we will find our equilibrium national income or equilibrium level of output. Let us try to do this. Here I substitute the value of C. Here we know this is the value of C. Because we have to find numerical value, we will take this one. Here I have written 40 plus 0.6y in place of y, and in place of I, that is investment, we have 60. So here I will write 60. Now here you can see we only have y which we have to find. So to find y, we want y to be in one side of equation. So we will send this y to the left hand side. So this left hand side will become like y minus 0.6, sorry, 0.6 is equal to 60 plus 40, that is 100. Now you can easily solve it. Here y minus 0.6y, sorry, here it should be y minus 0.6y means 0.4y, and this equals 100. Now if you further solve it, you will find y is equal to 100 by 0.4, and if you further solve it, you can find that this decimal can be removed, and due to this a additional 0 will be added, and you will find 250. This is the equilibrium national income we have found. And from this equilibrium national income, you may be asked to find this consumption. So when if you have to find the consumption level, first you will have to find this income, because you can see this in this consumption function y is here. So without finding the value of y, you cannot find the actual consumption level. So we have found the consumption level. Now we can substitute these 250 in place of y. So here you can write 60 plus 0.6 multiplied by y, that is 250, and if you solve it, you can find 40 plus, it will be 150, and it will equal 190. So out of this 125 250, 190 is the consumption level, and investment is automatically given, so you have not to find this. So these two questions may be asked. You may be asked to either find the output, or you may be asked to either find the consumption level. If you have to find only output, you can easily find it, but if you are asked to find the consumption level, you need to first find the equilibrium level of income, then only you can find the consumption level, that is equilibrium consumption level. Many a time when a question from two sector model is asked, there is no numerical value given, and you have to find the equilibrium level of this algebraic value of this y. That is all value, there will be no numerical value of equilibrium level of output. It will be in algebraic form. So first of all, we remove here, because I have already explained that concept. Here the question always will be y plus c plus I. So you have to find the equilibrium level of y, real output, or you can say national income, and consumption function is given like this, and this is the autonomous investment, which is represented by I bar, and this is the autonomous consumption, which is represented by C bar. So to solve this, what we will do, we will substitute the value of C and I in this equation. So when you substitute, you can write like here, in place of C, I write the value of C, and in place of I simply write this autonomous investment. So this is the equation which we have to solve for y To solve for y, you can see that this is one y and this is one y. So they both should be one side if you want to solve for y. So you will write here y is equal to y minus b y. Here it was plus, when it changes its side it will become minus, and now you are remained with this c bar and this I bar. And now you can easily solve it, that here you can take y as common. When you take y as common, you can write like this y, and in bracket here you can write y minus b, because here only y is left and here b is left. So we have y in into bracket 1 minus b, and this will remain same. Now you can solve it for y. Now y is equal to c bar plus I bar, that is autonomous consumption plus autonomous investment, and now in denominator we will have 1 minus b, or you can remove this bracket. So this is the equilibrium level of national income in algebraic form. So sometimes you may be asked in this form, so you need to remember this derivation, how this derivation happens. And this, if you memorize the derivation or you remember the derivation, you can easily find the value of equilibrium national income given c is equal to whatever. Suppose c bar is given 40 and autonomous investment is given 60, and this b is given 0.6, and you can see that we have found the same situation. Here it will be 100 by 0.4, and when you solve it you find 250. So you can simply apply this formula and find the equilibrium national income. This will save your time if you already know the derivation of this. But it is also beneficial because sometimes algebraic value can be asked in the exam, so you need to remember this derivation. And this is also used to find the multiplier, but here we will not discuss multiplier because here we are discussing only linear equation. To solve for multiplier we will need some another concept which will be taken in separate lectures. Now let us come to three sector model. As I have already told you that in three sector model we include government. In two sector model we did not have any government, and economy was self-functioning, but here we have government, and government spend something, government collect taxes. So in this model there can be three situations. One situation may be that there is no tax, is levied by government, and other situation is with tax. Any tax are collected by government, and tax are of different type, like there are lump sum tax, there are proportional tax, and there are subsidies which are also called negative taxation. So we will take up all these situations one by one. First of all, let us start with this without tax situation. So in without tax situation, this equation will remain the same, and the consumption function will also be given as we did it earlier. Like here, C bar will represent the autonomous consumption, and here beta will B will represent the proportion of income which is consumed. And now I is, again we assume that I is the autonomous investment, so we can write I bar, and government is spending is also autonomous. Autonomous means that it is not dependent on any other variable in the model. It is independently determined, so it is autonomous. So these you can see these three are autonomous components, and now we will try to solve it for national income equilibrium level. Now you can write this. What you have to do is you have to substitute these all values here in place of C. We have to write this, so we will write this, and this equation will become like this, and in place of I we will write this autonomous consumption. Here numerical value is not given, so we have to put this algebraic value, and here in place of G we will write the autonomous government spending. So this is the equation which we have to solve for Y, and similar situation will arise here. Y minus by is written because when this by changes side, its sign changes, and now here we have remained with C bar, that is autonomous consumption, and this autonomous investment and government spending. And here you can see, if you take Y as common, then in bracket you can write 1 minus B, and in right hand side other things will remain the same. And now if you solve for Y, you simply get C bar I bar G bar by 1 minus beta. This is your equilibrium level of national income. Now if the value of C bar, I bar or G bar is given, then you can simply calculate the numerical value of this national income. For example, suppose C is given something. Let me copy and paste here. C is given 40 as in earlier example, and I is 60, and we here add 50 government spending, and let the B remain the same, 0.6. Now you can solve it and you will find 150 by 0. And if you solve it, you can remove here. After solving this, you will find 375. So this is the equilibrium level of income. You can see, if we after adding the government spending, our equilibrium level of income has increased from 250 to 375. We saw in earlier example that our equilibrium level of national income was 250, but here we have 375 because we added government spending. Now let us introduce taxation in economy, and with tax model we will see first with lump sum tax. What happens when lump sum tax is levied by government in the economy? Now the model remains the same, y is equal to c plus I plus g. What changes is the concept of income. Now the consumption function is not the function of this income, but it is the function of disposable income, and disposable income is income minus taxation. After paying the taxation, whatever income is remained with you, it is your disposable income. That is what is this disposable income is, what you actually spend. You do not because taxation is not something you spend for your own needs, you pay to the government as the compulsory payment. So after introducing taxation, this equation increases and this changes, because in place of y we have yd, that is disposable income. So other things will remain similar, and we will substitute the value of c, yd and ig, and see what happens to this model. So y is equal to, here we will substitute the value of c, and now we will substitute here investment and then the government spending, and we have also yd given, so we have to substitute the value of this yd in place of yd. We copy, and in place of yd we will have to substitute this value. Now we have to solve it further to simplify it. Simply saying, you have to simplify it, and to simplify it, these all things will remain the same, but there will be a little change, like b will be multiplied by y, so it will be by, and this b will be multiplied also by tx, so it will be b multiplied by tx, which is the tax. Now we have to solve it. This y will change its side, that is, this will come to this side, and now we will have to write y minus beta y. So this is similar to earlier example, and this will remain the same, and other things like this will remain the same. Here notice that we have minus sign here because this is taxation, and taxation is subtracted, not added, because it is taken from us. And now similar concept will apply. Y will be taken as common and we will have 1 minus and b, and after this portion will remain the same, and after solving further you will find y is equal to autonomous elements by 1 minus b. So this is your equilibrium national income, and if some value is given, we can solve it for equilibrium national income. For example, suppose the value of C is given as earlier as 40 and B is 0.6, and taxation is let it be 20, so it will be multiplied by 20. P will be multiplied by 20, that is 0.6 into 0.20, and in place of investment we had 60, and in place of government spending we had 50, and here we will have 0.6. Before I solve this, just think a while whether this equilibrium national income will increase or decrease. I think it should decrease because taxation has been introduced. Let us see what happens. So when you solve this, you get 138 by 0.4, and after solving it, you will get 345. So this is now our equilibrium national income. I think it has reduced due to taxation. Earlier we had 370 and now we have introduced taxation, so our equilibrium national income is 345. And by substituting this 345 in this consumption function, you can find this equilibrium level of consumption. But I need to solve this because you may confuse there. Notice that this 345 is actual y, but the consumption is not the function of this y. This is the function of disposable income. So in place of disposable income, you have to substitute this value, then you can solve for the equilibrium consumption level. Let us solve it. I substitute this value. After substituting, this equation will become like this, and now you can easily solve it. C bar was 40 and B was 0.6, and you know it was 345 minus tax was 20. Now after you solve it, you get 235. So this is the equilibrium level of consumption with taxation model. And now let us come to another model. Now let us see the model with proportional taxation. So there will be no significant change, but only thing that will be that in place of tx we will have proportional taxation, that is small t and y. Small t shows the proportion of income which is levied as tax by the government. Other things will remain same, and in the similar way we will substitute the all values of these variables, like in place of C we will substitute this, and in place of I and G we will substitute the autonomous I and autonomous G, because we assume that investment and government spendings are autonomous. Now in place of YD we have to substitute this value, so we substitute this and we keep it in a bracket for convenience, and now we will solve it. After we will simplify it, we will get, I think this thing will remain similar. The changes will be that this B will be multiplied by Y, and this will also be multiplied by this T. So this will be our equation which we have to solve. you can see that here there are two y's, so both y will change their side, and here you will see y minus, first this will change sign, it will be minus by as usual, and this is the minus sign, so when you change the side it will be plus, and we will have by bty. So this will be our left hand side, and in the right hand side as earlier, in left hand side autonomous components will remain as always. Now what has changed, you can see that here when you take y as common, in bracket you have b, first you have 1, then minus b, then plus b t, or you can also write tb or bt, whatever, both will give you the same result. So this will be the change you can observe first time, because earlier we say there was only y minus b, but here we have y minus b plus bt, and this will remain same. And now when you solve it for y, you find autonomous component by 1 minus b plus bt. This is our equilibrium national income. Now if the values of these variables are given, we can find the equilibrium national income. For example, let us follow the earlier examples, like C was 40, I was 60, and G was 50, and B was 0.6, and here B was 0.6, and T is new, so in place of T we will assume 0.10, that is 10% is taken as taxation, so we can write 0.1, which simply means 0.10 or 10%. So when you solve it, you get 150 by 0.46, and when you solve this, you find 326.0.9, and this is actually the equilibrium output we could find. Now to find the equilibrium consumption level, you will simply substitute the values. Here you will substitute first of all yd value, in place of yd you will substitute this equation becomes like this, and after solving you can put all these values. After solving this you will find 216, and here I have taken the approximate value, not the exact value in decimal, so this value is also the approximate value. So 260 is your equilibrium consumption level if the equilibrium income level is given 326. I think you have understood it. You should try it on your own in your copy, because it is not possible to understand it without pen or copy, especially when you are new to this concept.